Good morning everyone. I'm Preethi from EC department. Today I'm going to discuss about least squares algorithm with Python code. Definition of a least square method: a form of mathematical regression analysis used to determine the length of best fit for a set of data points, providing a visual demonstration of the relationship between the data points. What is the least square method? The least square method is a form of mathematical regression analysis used to determine the line of best fit for a set of data points, providing a visual demonstration of the relationship between the data points. Each point of data represents the relationship between a known independent variable and an unknown dependent variable. The least square method is a statistical procedure to find the best fit for the set of data points by minimizing the sum of the offsets or residuals of points from the plotted curve. The least square regression is used to predict the behavior of dependent variables. The residuals are the offsets that will be told in the further section. Understanding the least squares method. This method of regression analysis begins with a set of data points to be plotted on an x-axis and y-axis graph. An analyst using the least squares method will generate a line of best fit that explains the potential relationship between the independent and dependent variables. Many optimization problems involve minimization of sum of squared residuals. For example, if we plot the data points, and the least squares method usually involves the fitting of best line for the data points. Then these data points will get some distance between the line and these points, and this is called as the residuals, in which in order to minimize these residual we'll undergo for many optimization techniques. So one of the best method is least square minimization, in which the residue or the objective function will be the r of xi is equal to yi minus f of xi. So the objective function is half sigma r of xi whole square. So we have a model that will predict yi given xi for some parameters beta f of xi is equal to capital X beta. From the definition of least square, we can say that the least square line approximating the set of points x1, y1, x2, y2, so on has the equation y is equal to a plus bx. Thereby the constants a and b are determined by using these two equations. These two are very important equations. Sigma y is equal to na plus b sigma x, and sigma xy is equal to a sigma x plus b sigma x square. The value of y on the least squares line corresponding to x1, x2, so on xn are a plus bx1, a plus bx2, so on a plus bxn. The corresponding vertical deviations are d1 is equal to a plus bx1 minus y1, and d2 is equal to a plus bx2 minus y2, so on dn is equal to a plus bxn minus yn. Here we will consider vertical deviations or perpendicular deviations to get the distance between the line and the point, but we prefer vertical deviations. So these are the vertical deviations for the points, and the sum of squares of these deviations is s, in which s is equal to d1 square plus d2 square plus so on dn square. So finally this s equation will become sigma of a plus bx minus y whole square. In order to get a minimum, the necessary conditions are dou s by dou a is equal to 0 and dou s by dou b is equal to 0. Thereby we get, on solving that, we will get sigma y is equal to na plus b sigma x, and sigma xy is equal to a sigma x plus b sigma x square. On solving these equations, we will get a value and b value. These two are very important. A is equal to sigma y sigma x square minus sigma x into sigma xy by n sigma x square minus sigma x whole square, and where b is equal to n into sigma xy minus sigma x into sigma y by n sigma x square minus sigma x whole square. These two are two important equations to get the line equation. For a concrete example, if you want to fit a quadratic equations to some observed data, then it will be f of x is equal to beta naught plus b1x plus beta 2x square. Therefore, the objective function will become L is equal to half sigma y is equal to 1 to I is equal to m yi minus f of xi whole square. So when we take derivatives with respect to beta, we will get dl by d beta is equal to sigma I is equal to 1 to m 1 minus f of xi, and sigma I is equal to 1 to m 1 minus xi f of xi, and sigma I is equal to 1 to m 1 minus xi square f of xi. We'll get the derivatives like this. So on working with matrices, we'll have the system of matrices f of x is equal to capital X beta. Therefore we'll get the matrix x is equal to 1 to x1 square and 1 to xm square. and so on, and beta is equal to b1 b2 beta 1 beta 2 beta 3. On finding the derivatives y minus x beta whole square, we'll get that elaborated equations, and when we perform dl by d beta t, we'll get x transpose x beta minus x transpose y. In order to make it minimum, we'll equate it to 0. Therefore x transpose y is equal to x transpose x beta. So let us see the code for this least square method using Python. First we need to import some modules which are required. So numpy modules, scipy and matplotlib for plotting, and scipy for scipy and optimize. So first we need to generate x and y. So x can be generated using numpy library using linspace function, and y will be some function 1 plus x into some random. So it will generate a random number from length of x. So we should assemble a matrix using the v stack, vertical stack, and then we'll turn them into, and then we'll turn y into a column vector using that function. And then we use the direct least square regression, which is used to plot the line. So it is given like that, and when we have printed this alpha, we should plot the results. So it can be plotted using plot function, and we'll label the axis as with using x label and y label, and we'll show this. All these figures and plottings and labels, namings, all were given, means all will be done using the matplotlib. And after plotting all this, we'll get the result as like this. And here blue dots represents the data points, and the red line represents the least square fit line, best fit line. And here we are having x-axis and y-axis. And this is the end of the code, and these are the references. Thank you.